Alright, so we finished up our evaluation phase. We'll do a little bit of our software, and then we will move on to talking about Project Prep 3, and let you guys have a little bit of time on that. So, I should have pulled this up already, but for your assignment, just to make this nice and clear because I can. So, let's see. Oh yeah, love me or hate me. We have a new data set. Yay! Guess what it's about?
Sure.
Sure. You guys are having so much fun with it that I wanted to bring it back. However, wait. Let's see. But wait for it, look. Better. It makes so much more sense. So it's a different data set. So you've got a customer ID. You have the gender of your customer. You have if they're a senior citizen or not. If they have a partner or not. If they have dependents or not. The tenure is going to be how long they've been with our company. If they have phone service with us or not. If they have multiple phone service. And this one's kind of nice because if the answer is no here, it tells you that there's no phone service. So it actually kind of helps you already. Tells you the kind of internet service, online security, all sorts of fun stuff, the type of contract, if they have paperless billing or not, their type of payment, their monthly and their total charges, and then if they churn. So a lot more classification variables, which actually lends itself to our networks, both Bayesian and neural networks, and a little bit more relevant information for you.
So, they have no phone service.
Yes, so they have no phone service. Then, if it has multiple lines, then they can't. So there's no phone service. But they could potentially have internet service with us, even if they don't have phone service with us. So, and then once you have internet service, so if you don't have internet service with us, then the next 1, 2, 3, 4, 5, 6 of these. So you may have phone service, but no internet, or you may have internet but no phone. And so it's just nice and it actually helps you out to say, do they have online security? Yes, they do, no, they don't, or they don't have internet with us. So it's already kind of sorted for you, so you guys don't have to worry about filtering or anything like that. Yes.
Charge and total charge. If I wanted to use those, I would have to get
Yes. 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 So if you wanted to use monthly charge or total charge for a naive base, you would have to bin it. Or you can let the software bin it. But if you want to have more control over what the bins are, then you would want to bin it. So you've got a data dictionary that tells you all the things. That's where I found it. Go Kaggle, Kaggle. There was another data set that had like 100 telecom variables that I almost did. That's what I thought. So I thought, but anyway. So hopefully this one will at least give you a better idea of what churn really can do. So your assignment, you're going to get to do a little bit of data understanding and preparation. Right? So this is kind of what you did for your decision tree assignment. I've been grading your decision tree assignments. About half of you have grades right now, half of you don't, because I fell asleep. What happened last night? I fell asleep. Sitting on the couch, typing away, fell asleep. So the rest of you guys will get grades hopefully tomorrow. But you're doing really well right here, providing, really what I'm looking for here with the provide at least 3 key insights, just giving you 3 visualizations that kind of fit the big picture. Big things that we're going to make sure to do, you know, if you're talking about churn, visualization about the amount of churn would probably be a good visualization to provide.
Maybe a pie chart.
I mean, I will say you guys want a little pie chart crazy. As long as you're just looking at like 2 things, yes, no, churn, yes, no. Pie charts are fine. task 2, basically, I made it even easier. You're going to try different options. You're going to fill in the chart. This assignment, I'm trying, like these next few assignments, you guys have been doing a lot. You have been working really hard in this class. You've been writing a lot, you've been doing, so I'm trying to back this down. So if your association analysis hopefully is a little bit faster, this naive Bayes, your neural network, there are fewer points, so I'm trying to make sure that you guys don't go crazy. And you guys are great overachievers. And I love that about you. But I'm just trying to give you a little more constraints, right? So just really, you're just kind of filling in the blanks, trying some different models. I think this is this should be the updated one that actually makes sense. And then for task 3, it's just an elevator pitch, right? So same idea. What'd you find? Which one is your best model? What can you tell me? And then have fun choosing your own adventure. The only thing you can't do here, we actually don't have a SAS Via tutorial. I don't make tutorials. So you can't critique that one. You can critique the Sassy M one, but we don't have a SAS Via tutorial for you to critique. Here, have fun. Do what?
We can just say there's no tutorial, and you get 3 points.
Well, no, that's why you gotta do, and this one over here too. So you get 1.5 points for saying there's no tutorial. You get 3 points. I'll give you 4 points. How much is it worth? 3 points. I'll give you 4 points out of 3 points if you make a tutorial.
How good of a tutorial does it have?
I mean, how great are they already? And then you can have fun, right? So use SAS Via, or use the model builder. Give you guys a little more chances to explore. Expand your SAS Via knowledge. Just try something different. Let me know what you found. Research, right? So if you want to get into what all of these different methodologies are, spend a little bit of time researching. Tell me a little bit about them. Get some points there. Or, I mean, 6 is kind of fun too. You can just really choose your own adventure. As long as it's related to data mining, anything that you find interesting, use your time. So those are your options. So keep it nice, keep it simple, play fill in the blanks, and then obviously you're going to identify which one is your best model. You do not have to stick to this fill in the blank. You are welcome. If you have another format that you've been using that you like, you're welcome to use it. But I'm just trying to give you an idea of this. This is also, when it says variables used, if it's easier to tell me which variables were not used, as opposed to which variables were used, that's appropriate as well. Okay? So you may say we use all the variables except these 2. Would be a whole lot easier than listing out 18 variables. You can also list it out once somewhere above, and then, quotation mark, same as above kind of thing. Okay. So you don't have to retype it or copy paste it every time. Any questions about your assignment? So really the big thing is just some exploration. So since we're going to do some exploration, let's go and explore. Shall we Via? You guys want to Via? Or you just want to do it? Yes.
Now that we are in Via, I just had a question regarding the decision tree assignment which we did, right?
Uh-huh.
So what happened was that once we put the parameters and we get the first decision tree in that Via, that is always the best. Whatever we change, it just kind of makes it worse in the validation. But how do we really determine how that got formed and not implemented? Because when you do auto-tune, it's something worse.
So the auto-tune surprised me.
Yeah.
Right? So sometimes I found the auto-tunes worked better. A lot of the times you guys came up with much better, like just by tweaking it and changing it, you came up with better ideas. So the auto tune, all it does is it only changes 2 different parameters. You still have the ability to change 4 or 5 different parameters. So I found, like, as I've been doing it, because the auto tune is totally new to me. So as I've been playing with the auto tune, I found that it works better for estimated tasks than it does for classification tasks. I felt like I could make a better, like by looking at it, kind of seeing what I wanted, I could make a better classification task. But it, because one of the parameters that it changes, I think, is the binning options. It went through different binning options to try and make better classification or better estimations than I did.
But all of the, I think all of this is working only with the training, because it's all improving the misclassification rate in the training.
Yes.
But the validation, they're all worse. So means everything is making it more overfitting.
And then that may be the thing, right? So if you're doing the more of the overfitting, the auto-tune may not, like, it's a cool idea, but I don't know that it's the best thing to use, just for that reason, right? So it's like, yes, you make the model better, but if I put in new data, it doesn't help. And so yeah, so I wanted you to try it, and if it was going to be like, oh, but it's not. Like, I wanted it to be like the answer, like you go in, you push the button, and this is it. But it's really not. Take a look at you guys and the insights that you found. You thought it was going to be this, but it wasn't. Alright, so let's go into a new report. Again, if you guys want to follow along, you're welcome to. If you just want to sit back and watch, that's fine too. We do have a ISYS via video. It just got posted last night, so I'll get it uploaded into your class today. We don't have a tutorial, like I said, so I thought I would make sure to kind of go through this with you. By now, I think you guys are all kind of VIA experts. You could probably figure this out on your own, but let's do this. So the data we're going to use, I like eBay. Where is eBay? There is eBay. Where is eBay? So much. There we go. Alright, so now I have it in memory, so now you guys hopefully should be able to find eBay. Are you there if you want it?
I'm not.
It's not showing.
Refresh and try again.
Okay.
Yes.
Now is it there?
Oh, got it. Okay.
Well, it wasn't. It was hiding. It wasn't in memory, so we gotta get it into memory for us. Alright, so we've explored our eBay data. We know there's a bunch of different categories, some currencies. We have the days that it ended on. We've got our 7 different days of the week. We've got our closing price. We've got to go to competitive and change that to a category. So one of the things, as we're here, and kind of waiting for you guys to catch up, my Saturday class ran into an issue when they imported the data for actually your turn assignment. When they imported the data, everything imported as a categorical variable. I don't know why. But everything came in as a categorical variable. And so we were like, well, that's not a big deal. I'll hit categorical, and I'm going to try and change it to a measure. But that's not an option. You can change a measure to a category, but you can't change a category to a measure. Dun, dun, dun. So we did a little research.
Zero dash.
Do what?
Was it zero dash? when I ran through that in some other data set, like instead of 0 it was dash, then it becomes a category.
Maybe. So yeah, so you may be able to go to the Excel file, fix something there. I took the Excel file and I changed it to a number, and I did a couple different things. I still couldn't get it to work. Try it. See if you figure it out. If you can't figure it out, we have a workaround. And the way you can work around it is you can actually create a new data item. Add new data item. And then you can actually create a new calculated item. And then here, so we've kind of played with this just a little bit before. One of the tutorials kind of went through this. You can actually, I changed it to text, and I can actually type in whatever I want to right here. And so I don't remember this off the top of my head, but I'm pretty sure it's something like this, and we'll see if I get it right. We're going to parse the data. And we're basically just going to, so in this case, it would be some character, so maybe this isn't really good because there is no number. But if there was something that we could change, you could actually come over here, change it. You add a comma after, and type in the word, comma, 14 points. And that's just kind of telling it what format do you want it in. All right, so I want it in decimals. And if you actually ran this, it would actually take this categorical variable that should have been a measure anyway, and change it into a measure. So if you run into the issue, and I'll post this on the discussion board, parse, select the variable you want, change it to the formatting that you want, and you're good to go. All right, side note. All right, so we have our data. We made competitive a categorical variable. Close price, duration, frequency, open price, and seller rating. So right now they're continuous variables. So we could go in and we could decide that I want to bin all of these variables. Can we do that? Is there an easy way to do that in ISYS? I'm pretty sure if we add a new data, you guys have been like pros at this. Somebody tell me, what's the easiest way you found to make a bin? Excel? Excel? Anybody playing Satisfied? Anybody? Hey. I'm thinking probably a new data item would be one way to do it. And you can actually create a custom category, right? So instead of creating a calculated item, we're going to go the other way. We can do a custom category. And you can actually figure out how we want to do this. So I want to base it maybe on, what do we want to base it on?
Close price.
Close price. Okay, we got close price. Close price gets a little crazy. Look at all these different close prices. So it says drag values here. That seems a little bit. So group by, we can group by distinct values. We can group by intervals. Probably more what we want to do. Let's group by intervals. And so now here it even gives you kind of like this nice little histogram where the intervals are. So we can click or drag interval here to add an interval. So maybe we want to go from 0 to 50. Because I can't get 50. So you just type it in, 0 to 50. That wasn't it. Oh, or you can just type it in. That's fun. Just type it in. That's cool. 0 to 50. And then maybe, looking at our little bar chart, maybe I'll go 50 to 100.
This is the same value when you add another value. They're on the top. This.
Oh, nice job. Delete. So value group 1 is going to be from 0 to 50. So then I want to add value group 2. Nice job. And that may be 50 to 51 to 100. And then just because I don't want to do this a whole lot, value group 3 is going to be 100 to 999 or 1,000.
See 101.
101. Thank you. Do 1,000. So there we go. So yes, you're welcome to use external. But look at us, we just figured out how to use Bio.
Sorry for being picky, but this is missing all the values from 50 to 51 and 100 to 100. We will continue to do it. The price of 50.5 even.
49.99. How about that? Let's do 49.99. No, see, you make good points. I love it when you guys make good points. To 99.99. 100 and move that 1,000 should hopefully be right. See, knowing the units that you're working with, very good idea. Alright. I'm just going to click OK. So like I said, so I made it into 3 categories, and it's custom category 1. That was kind of silly. I don't want to call it custom. So what was this? This was our close price. Cat. What do you guys think? So we're going to do both. We'll use both the closing price as an interval, we'll use the closing price as a category, and we'll see if it changes our results. So we have our data, right? Step 1, our business understanding we've already done. Step 2, our data understanding. Step 3, our data prep. So we're getting our data all prepped, ready to go. Step 4, here comes the models. So we're going to hit Object. Down at the very bottom, we're going to find under the SAS Visual Data Mining and Machine Learning, we have Bayesian networks. We're going to click and drag it. All sorts of fun. So now we have to go in and type in all of our information that we need. So Bayesian network, that's totally fine. You can mess with the style and the layout. We're not going to worry about that. So the thing we really care about is actually getting into the Bayesian network piece. So our general, well, we have no event selected. I guess we need some data first. So I'm going to go to roles. Before I mess with the options, I should probably go to roles and probably get my data in. So I've got response, predictors, and what did I forget to do? The partition. So I'm going to go back to my data. I don't know why I forget to make a partition in SAS Via all the time. If you have forgotten to do a partition in your SAS Via on one of your assignments, I'm going to kind of give you a pass. Because I forget it every time too. However, for your next 2 assignments, try really hard. Right? Just because we're in a different software doesn't mean the foundational idea of data mining, using a training and using a validation data set, have gone out the window. So just because I don't do it doesn't mean you shouldn't. But since we remember now, I'm going to go in, I'm going to make my partition real quick. Partition based on sampling is simple random sampling. 2, I'm going to do 60%. My random number seed is, I like 1, 2, 3, 4, 5. Alright, now we've got our partition. And I assume that you all are very well acquainted with that, even though I forget to do it. Alright, let's go back to this again. My response, my target. I'm trying to classify, is this competitive or not? My predictors, it says I can use all of them. So I'm going to use all of the original variables to start with. The category, the currency, the end date, the closing, so the measure value for closing price, duration, opening price, and seller rating. So even though it's a Bayesian network, and even though it needs all classification variables, SAS Via is saying, I can handle this. Click OK. I'm going to go ahead and add my partition. So I'm going to go up here. I don't like the validation key I showed in. I really like the... So something that I think will become very interesting for you all, and I don't think I've explained this well, so I want to. You have a validation misclassification rate and a validation misclassification rate for the event. So when we have binary ones and zeros, the validation misclassification for the event and the overall validation misclassification rate are going to be the same. Okay? But some of you in your decision tree model said, you know what, even though, Dr. Kiefer, you told me to estimate this, I just don't think that's a really good question. And really, I would like to bin the years at company. I don't want to just estimate the years at company. I think it really looked good in the bin. You know, 0 to 5 years, 5 to 10 years, that kind of thing. Which worked out really great. But then you were trying to give me the misclassification, and you were struggling. Okay. This happened in both of my classes. The reason is, when you have more than just a binary, when you look at the misclassification rate for the event, you have the event equals 1, or the event equals 0. But if you have 5 categories, you can actually get the misclassification rate for 0 to 5, and the misclassification rate for 5 to 10, and 10 to 15. Okay. So if we were going to try to predict the end of day, or sorry, the closing price using the category, we would have 3 different categories. So our validation misclassification rate for our event wouldn't match the overall misclassification rate. Okay, so just to point that out, what the difference is between those two. But so here we are. We have a overall validation misclassification rate of 33%. I don't remember what it was for our other models, but we're just not real good at figuring out if these things are competitive or not. The closing price seems to be pretty important. Seller rating, duration. So really it's looking like the continuous variables. If they're not continuous, we group them somehow. So how do we group them? How do we understand? How do we learn more? Yes.
What is this BIC score?
It's the thing that I really hoped nobody was going to ask me about. Hey, you know what it is? It is a great opportunity to choose your own adventure. See how I did that? It's the Bayesian information criteria is actually what it stands for. A lot of the times when we'll do, when we started doing the regression, there was like all these different error metrics that we could use. So we have the BIC, we've got an AIC, you've seen the root mean squared error, you've seen all these different types of things. It's just one of the options. And in this case, so like, before you see it, this is like importance. And you're like, I don't know what it means, a longer bar is better. I've asked that on several people will have a little comment. It's like, this is great. What does it mean? Here there is action interpretation. If you Google it real quick, you can figure it out. It's not something I have stored in my brain. But it stands for Bayesian information criteria. Basically, it is the same idea. The closer it is to 0, the higher or the more important it is. But I don't know where there's an upper bound or a lower bound. But yes, great thing to find out all about that. 3 points. Yes.
This classification rate thing which you said, I'm not sure I understood clearly, but the only thing which I want to ask you is, should we use event or should we use our other one when there's more than 2 categories?
So when you're talking about it, I would use the overall.
Okay.
So in that case, I would just use this overall misclassification rate.
Okay.
So, side note, I'm going to change something real quick. We're going to come right back here, so don't follow along. Okay. So if instead we wanted to change the response to, yes. get the closed price category. Well, yes, I know. I'm going to get rid of closed price. That's obvious. Okay. So now, this is the event for group 3. If I would have named group 3 better, it was going to be the $100 plus, right? So, being able to classify $100 plus, I've got an 11% misclassification rate. But if I wanted to classify the...
You have to choose the event.
No, do that with me.
No, you have to choose the event there, the next one. We have kept the bigger one, no?
Right, so I changed it to value group 2.
No, the second
Oh, I see, I actually. So, there we go, thank you. So the overall misclassification rate is 11%. If I change it to the event, now my misclassification rate for that $50 to $100 is 5%. For $0 to $50 is 11%. And the thing we didn't look at is 6%. So what I'm finding out is that I can predict the closing category price better for the higher values than I can for the lower values. So overall, 11% misclassification, but I can figure out which categories I can predict better. Next. Now returning to the original. So we want to add back in closing price. Our response is competitive. So things we have here, let's go back. So let's go look at our options now. So in our options, we have our Bayesian network. So here it's looking at event level 1, and here's where we can choose what we're going to look at. If we wanted to include missing data, we don't have to worry about that because we have a good data set. Do we want to use variable selection or not? So right now, I've got a 33% misclassification rate using all the variables. Maybe I want to use some variable selection. Didn't really do anything. So whether we're looking at the overall, it doesn't matter. So variable selection, there's not a lot of variables there, so it's not really kicking anything out. This, we're not going to focus on which type of independent test statistic we're going to use. We're just going to leave the default. But here's the network structure, and these are the things that we're going to try the difference of. So we have a naive approach, which is what we learned to calculate. And we have these other three. So down here in the bottom left, you'll see that here is the misclassification rate. This is the number of parents that are being used. And so misclassification, you'll notice that these are all the same, right? We got 0.355, 0.345, 0.335, so we're looking at 33 versus 35%. And the star actually shows you which misclassification rate is the lowest. So out of the Markov blanket has a 35, almost 36% misclassification rate. The naive, the parent-child, this one, the tree-augmented naive, is going to have the lowest misclassification rate. So basically what I'm asking you to do in your assignments, it kind of summarizes right here. Right? So you tried 4 different types of models. This one's the best. This one's not always the best, but this one's, yes.
It isn't like the other techniques we use where you had to go and select individual ones, you can just do them all at the same time.
Right. So if you want to get, so it's 2 things, right? So it'll let you do it all at once. The only bad thing about all at once is that when we expand and we try to look at things a little bit more, it tells us actually lets you know, so here's the best structure is the tree-augmented naive. Here's the attempted structures. So it tells you, and again, I don't expect you to get all the way into all this detail, but as much as you want to learn, it's here and it tells you what it did, right? So it tells us about the number of observations we used. It tells us where we split how many went into the training, how many went into testing. We can go look at the fit statistics. There's that BIC score. Don't know what that means. You'll know next time, though. Right? Has our classification rates. The model selections, it actually goes through and says, here's the different model selections, here's the different things that we tried, here's the different structures that we used, here's where they're changing the number of parents, because it was trying several different things. Okay, so this is basically your model comparison. So when I'm looking for these values, they're right here. The variable selection procedure, I didn't really like any of these variables. But here it also has your conditional variable, right? So when you see, we go back up. So competitive being our target variable, it says, what are the conditional variables? And it says it's going to closing price. So you kind of see those connections of how they're happening. The variable levels, variable order. Those are some values for that. Misclassification. So here's your misclassification. Right, because I asked in the assignment, I asked for true positives and false positives. Well, this only gives you for your best model. So this will help you know which one's your best model. But to actually be able to answer the question on your assignment, you do actually have to go in and deselect. So then when you see naive, this is going to be your false positives and true positives for the naive. And you'll see which parents, right? So it's tried 5 different parents, and it says 2's the best.
What does that mean? It's tried 5.
So remember how I said you could have, and this is kind of just the structure of how things work. The parents means how many they can connect to. So parent to child, parent to child, parent to child. Just what arrows are coming out of. So it's going to say, so this picture right here, you'll notice that it has 1, 2, 3, 4. Why does it have 6? It should just be 1, that one should be 1 to 1. I don't know, I'm going to have to look on that one.
Maybe one of them has an error going back to the...
Well, but this one's naive, so it can only go from here to here. I don't know, let's find out. We have a set of parents. There we go. Set of parents. For each node, it considers all sets of parents up to the specified maximum size and updates the network to include the best set of parents for that node. One parent iteratively adds the best remaining predictor as a parent. Iteration stops when there are no more candidates or the number of parents reaches the specified maximum. So this is going to go in with just, I always like to see how different softwares do things. This is just going to be part of the process, right? So it's a network building. So we were just looking at naive Bayes just from a basic perspective. We were looking at it with one parent. We weren't doing anything. The number of parents seems to be kind of the number of iterations that it will go through. So we'll talk, and the iteration thing will make a whole lot more sense next week when we actually talk about the neural nets and we talk about how all the iterations work. Here, we're just trying to build a model. And so we'll try some different iterations, trying the different types of parents. Oh, that doesn't really help. That's not nice. I fixed it.
So, how would you use this model?
So really the big thing is, and this is the hard thing that I find to kind of comprehend about when we're doing this data mining stuff. And well, here, let's see if this works. I don't know if it's going to work. I'm going to take 7 minutes, and if it doesn't work, we're going to ignore what I just did. Okay. Before I do that, the basic idea here and what you're trying to do is you're just trying to find the best model with the lowest misclassification rate. Does that part make sense?
Yep.
So you're using the software, you're trying to find the best model that gives you the best classification rate. So then the question would be, how do you use it, right? Well, so in this case, we aren't actually privy to all the stuff that's going on behind the scenes. Like from the naive, with one parent, we could show you the calculations. But once it starts doing an iterative process and trying out multiple parents, now it's kind of up to the software. And what did the software do? So somebody had to program the software. So we could actually go in and figure out what did they program. We could follow it through, and we can do it by hand. But trying to reverse engineer what happened, not the easiest thing. So how we would actually practically use this would be crossing my fingers as such. So up here at the very top, we kind of saw the create a pipeline idea. So this is my very simple naive phase network. I would create a pipeline, and we're going to add this to a new project. So visual analytics is helping us visualize what's going on. But it doesn't do a lot of the heavy lifting. So SAS Model Builder actually lets us do a little more heavy lifting. And this is what the pipeline is. So it's Enterprise Miner, the Model Builder is very much like Enterprise Miner. So this is why you don't do live demos. So what we're going to do here in a minute is we're actually going to, now that I'm thinking about this, I'm going to need something extra. So really quickly, so I'm going to go to our eBay auctions. This is actually a perfect time to do this, so I'm glad you asked. So here's our eBay auctions. I'm going to take, how do I do this? So we have a data set that has 1,000, almost 2,000 rows. So what I'm going to do, because this is, I don't know how this is sorted, I'm just going to randomly delete a whole bunch of stuff. And my goal, what I'm going to do, I'm going to get down to a data set that has about 10 data points. Okay. Here's what I want you to believe. We're going to have 20 data points. And so what I'm going to do, alright, so it only has 19. So I'm just going to put this in a Word document real quick. So what I'm going to, the reason I'm doing this is I want to know what the actual values are so we can compare them later. And now what I'm going to do is I'm actually going to delete the competitive. So the way that we would actually use this, okay, I'm going to take this, I'm going to save it as eBay auctions _ scores. Oh, that's just now I'm going to go to my data. I'm going to figure it out here in a second. Okay. So I created a pipeline. Did you guys push the pipeline button? Did it work? Okay. So create a pipeline. So here's my original data. Here, this is the interactive data preparation. So this was the thing that we went in and we changed the variables, we added them. This was what happened over in SAS Visual Analytics. Here we have our interactive Bayesian network. So again, this is what was happening over in SAS via the Visual Analytics part. It created and found our best Bayesian network. Well, now what I'd like to do is, there we go. So I want to add the load. What I'm going to do is I'm going to, oh, don't do that to me. Where were you? Let me push one button. Remember I said we're not going to pay attention to this next 7 minutes. Alright, so I'm not going to show you how to do this in Via because it says I have to, well, it says I have to import SAS code and I don't have that handy. So I will, however, show you how to do it in Enterprise Miner, which is what's really cool.
And is what the goal is to like
New data.
right and to
Figure it
like
out.
classify it based on okay.
I want to show you because it's cooler if I show you. But yes, so the goal would be, from a theoretical perspective,
Right.
is you create a model. No matter what that model is, no matter if you can or can't explain it, you create this model and it's the best model. And then you're going to take new data, run it through the model, and it will spit out answers. So that's your goal.
Yeah.
Some models, decision tree, you have a method, you have rules, you could actually explain what happened.
Right. Okay. I think that's just what I.
Yep.
Because that's what we've done the last kind of 2 times. That's like, wait. This
Linear regression, logistic regression. You have a model. You can plug in. You can talk about the coefficients, the slopes, the odds, what happens.
Right.
So, linear, you're good. Logistic, you're good. You got models there. K-nearest neighbor, you can find nearest neighbors and describe things based on those nearest neighbors. Decision tree, you've got a set of rules. Once we hit these networks, so this one kind of starts it. When we hit to neural networks next week, you guys are going to be like, really? Neural networks it's a black box. Like you can't think back through it and figure out what the heck the algorithm did. So you start out with conditions, and if you did it by hand, you could follow the math, but you can't reverse engineer it and explain what happened. So you just have to, this is based on these parameters and all these different things that we tried. Here's my best model. I'm going to put information in. Black box, you don't need to know what's happening. I'm going to pop some information out. Assuming I did my job right, you should trust what happens in the middle.
Yeah.
That's really what's going on. Right, so like if we were using it for the loan question, right? So we had not just the size of the company and if they've had bad things happen in the past, and bad court cases in the past, but we had 5 more variables. Input a new case based on all these 5 variables, stuff happens, and all you're going to get at the end is, yes, you should go check it out, or no, this is probably fine. So this is the thing that is really fun that we're still working and trying to figure out and how it all connects. We have gotten it where we can actually start here, and then we're able to now push it into Visual Analytics, which is kind of fun. So we're working on getting all this stuff happening, but again, this is new software and we're still playing. So back to, this is the best way I know how to do this. back to my report. Do you guys have any questions about this aspect of doing the naive base?
Did you, like, how do you interpret the visual, like, the visual, like, where the target's in the middle, everything's around it, like, I'm so confused, like, what?
You really don't have to.
It's there.
It's just there just to show you kind of like, here's all these variables and here's how they relate. But they're like, you wouldn't be making any decisions based on that.
Okay. I guess because like thinking like the association with the link
Yes.
graph, that makes a little more sense. 'Cause
Yes.
It's like, oh, these things go here and here, but
This is
just
not a link graph.
that. Yeah.
No.
Okay.
Really, I find it's just a pretty visual.
Okay.
Unless you're really starting to try to like dig in and understand what's going on. I don't find it very useful. I'm gonna get that to it. Some stuff here really well. There we go. So yeah, so this idea right here. So we're looking at competitive is related to close price, competitive is related to seller, competitive is related to duration. Duration is also related to currency and end day. And it's just how the connections and which conditional probabilities match. So if we went back and looked at the variable selection, here we should see the conditional variable on close price and category. I'm not gonna lie. Apparently, I do not understand best buy as well as I thought I did.
But now I think I understood what the two parents actually mean.
Yeah, now that we actually saw
Yeah.
that, it looks like the two parents. I didn't realize naive base did that, because that's kind of not what it is in the purest form. So I'm going to have to dig in and see a little bit more if I can find out why it's doing the multiple parents here. Which is funny, because when you look at, we looked at all of them, right? Our best model was the tree augmented naive. And you'll notice that it only has two because it only allows for two parents. So it doesn't have, it's not trying out anymore because part of its fundamental concept is that it only allows for two parents. There we go. So would you like to see SAS Enterprise Minor? Or would you like to spend about the next 30 minutes working on your project cut 3 after I tell you what it is? So I have some more, like if you look through your PowerPoint, I did some stuff in SPSS, kind of talking about which predictors were better, using the probabilities to answer some questions. They're there if you want to dig into it a little bit farther. But since I tell you not to use it, I felt like going farther down that rabbit hole wasn't the best way to do it. Adding on to naive Bayes, you know, a lot of the things that we've looked at in the past fit on multiple blocks, but naive Bayes is the only one that fits on only one block. Right? It has to be a categorical target. It has to have categorical predictors. Right? Fun test question. Out of all of these, which one can only be or only uses categorical variables? All right. So let's spend a couple more minutes.